Okay, so get this. A black hole taking a nap.
A black hole taking a nap.
You heard that right.
Hmm?
We're diving into a discovery
Huh?
that is really kind of shaking up the world of astronomy. We're
Yeah.
talking a supermassive black hole,
Yeah.
early universe, and a whole lot of mystery. And to guide us on this journey, we've got a research paper straight from Nature
Oh, wow.
and a breakdown from the debrief to kind of help us wade through this.
Sounds like a good plan.
So let's see what these cosmic detectives have uncovered.
Well, you know what's really captivating about this discovery is that we're talking about a supermassive black hole,
Right.
a real cosmic heavyweight, and it formed unbelievably early in the universe's history.
Hold on, how early are we talking?
Well, the James Webb Space Telescope spotted this behemoth just 800 million years after the Big Bang.
Wow.
So that's practically a newborn in cosmic terms.
Right.
And get this, it's a whopping 400 million times the mass of our sun.
400 million times.
Yeah.
That's a lot. I mean, even a regular black hole is mind-boggling. But 400 million times the mass of our sun. That's on another level.
It is. And here's the kicker. This giant is hanging out in a surprisingly small galaxy. So we're talking about a black hole that makes up a gigantic 40% of the galaxy's total mass.
Wow.
Usually they're only a tiny fraction, like 0.1%.
So it's like finding a whale in a swimming pool.
Yeah.
Something just doesn't seem right. How could something this massive form so early in the universe's lifespan?
That's the million-dollar question, isn't it?
Yeah.
And it leads us to the other fascinating aspect of this discovery. It's dormancy. This black hole isn't actively gobbling up matter like we typically imagine. It's consuming just a tiny fraction of what it could.
Wait, so it's like a black hole on a diet.
Exactly. It's more of a gentle nibble than a ravenous feast. Think of it like a bear in hibernation after a massive Thanksgiving dinner.
So we've got a supermassive early bird black hole that's taking a cosmic nap.
Yeah.
Now, I'm no astrophysicist, but that sounds like it breaks a few rules.
You're picking up on something crucial to understand why this is so strange. We need to talk about the Eddington limit. It's like a cosmic speed limit for how fast a black hole can gobble up matter. But this one, it's like it hit the gas pedal way before the speed limit even existed.
So this black hole is breaking the cosmic speed limit. It shouldn't be this big this early in the universe.
Yeah.
That's why scientists are scratching their heads.
Precisely. And it's got them questioning everything they thought they knew about black hole growth. One of the researchers even said, it's possible black holes are born big. That statement alone has sent shockwaves through the astrophysics community.
Wow. Okay, so we've got this cosmic rule breaker.
Yeah.
How are scientists even beginning to explain this?
They've come up with a mind-blowing idea called the start and stop growth model. Imagine a black hole going on a crazy feeding frenzy, like a cosmic vacuum cleaner on overdrive. It sucks up everything in sight, growing super fast. Then it just chills out, takes a nap for millions of years. That's the new idea scientists are proposing.
So what we thought was a constant process might actually be bursts of activity followed by long breaks.
Exactly.
This could change how we understand black hole evolution entirely. But wouldn't that require some unknown mechanism to control these cycles? Isn't that a bit of a leap?
It is a big leap, and it's definitely sparked a lot of debate. But it seems to be the best fit for the observations so far. These periods of hyperactivity could explain how a black hole could bulk up so quickly in the early universe. It's like saying instead of eating one burger a day, it scarfs down 100 in an hour, then fasts for a month.
Okay, that analogy is definitely helping me wrap my head around this. So it's not steady growth, but more like cosmic binge eating, followed by a long cosmic siesta.
You got it. It's a pretty wild concept, right?
Wild is an understatement.
Yeah.
And you mentioned this model helps explain how this black hole got so big so early on. Can you unpack that a bit more?
Sure. Let's go back to that early universe, a time when things were chaotic and hot. Imagine a massive cloud of gas, the kind that forms stars. Now, instead of slowly forming a star, this cloud is so dense and massive that it just collapses in on itself in an instant.
That's incredible. So instead of a slow burn, it's more like a sudden explosion inwards.
Exactly. That's what's known as direct collapse. It's a shortcut to forming a black hole, bypassing the whole star formation stage. And it could be the key to understanding how supermassive black holes like this one form so early in the universe's history. It's like building a skyscraper. Normally you build floor by floor, carefully putting each piece in place. That's like star formation. But with direct collapse, it's as if the whole skyscraper just crashes together at once, forming a massive structure in an instant.
Wow, that analogy really paints a vivid picture.
Yeah.
So this discovery is potentially rewriting the book on how black holes form, especially in the early universe.
Absolutely. It's a potential paradigm shift, adding a whole new dimension to our understanding of these cosmic giants. But here's another puzzle. If these dormant black holes are so common, how come we haven't found more of them?
Well, you did say they were kind of like cosmic ninjas hiding in the shadows. Is it just that they're harder to detect?
Exactly. Think about it. We can't actually see a black hole directly. They're black, literally. So astronomers have to get creative. They have to look for clues, like a detective searching for fingerprints.
So how did they find this particular cosmic ninja, this dormant black hole?
That's where the amazing James Webb Space Telescope comes in. It's like having a superpower that lets you see through walls.
Okay, I'm intrigued. Tell me more about this cosmic X-ray vision.
The JWST is incredibly sensitive to infrared light. That means it can peer through clouds of gas and dust stuff that would normally block our view. It's like having a special flashlight that reveals hidden objects in a smoky room.
So they used the JWST to look at the galaxy where this black hole is hiding, and they saw something unusual.
Precisely. They noticed that the light from the galaxy was being distorted, kind of like looking through a funhouse mirror. The image was warped and stretched. That's a telltale sign of a massive object lurking nearby, bending the fabric of space-time itself.
So even though they couldn't see the black hole directly, they could see its gravitational fingerprint on the surrounding light.
Exactly. It's a testament to the incredible sensitivity of the JWST and the ingenuity of the astronomers who are using it to unravel the mysteries of the universe.
It's like they're cosmic detectives piecing together clues to solve the universe's biggest puzzles.
That's a great way to put it. And they don't work alone. The research papers mention a team from the University of Cambridge leading the study, but they also worked with Italian colleagues to build computer simulations.
Wait, simulations? Like video games for black holes?
Well, not quite video games, but you're getting the idea. These simulations are like virtual laboratories where scientists can recreate cosmic events and test out different theories.
So they use these simulations to see if their ideas about this dormant black hole could actually work. Like, could the start and stop model really produce a black hole like the one they observed?
Exactly. They basically fed all the information they had into the simulation, things like the amount of gas available in the early universe, the time frame, and they even tweaked how long those growth spurts might last.
And what did the simulations show?
The results were pretty amazing. The simulations actually supported the start and stop model. It was the only scenario that could produce a black hole with the characteristics they observed.
So it's like the simulations provided the missing piece of the puzzle, giving more weight to this whole cosmic binge-eating idea.
Right. It was a huge boost for their hypothesis. And simulations are becoming increasingly crucial in astrophysics.
Yeah.
It's like having a time machine that lets you witness the birth and evolution of stars and galaxies.
That's mind-blowing.
Mm.
So we've got observations from the James Webb Space Telescope. We've got computer simulations backing up the theory. Seems like we're really onto something big here.
We are. And this is just the beginning. One of the researchers, Ignace Wood-Wallace, said something that really struck me. He said, "It's likely that the vast majority of black holes out there are in this dormant state." I'm surprised we found this one, but I'm excited to think that there are so many more we could find.
Wow, that's like saying we've been looking at the tip of the iceberg this whole time. There could be a whole hidden universe of dormant black holes out there.
It's a tantalizing thought, isn't it? And it opens up a whole new frontier in astronomy. We've spent so much time studying the active, flashy black holes, but what about the silent majority? What role do they play in the grand scheme of things?
It's like realizing there's an entire ecosystem we haven't even begun to explore.
Exactly. It's like discovering a hidden rainforest teeming with new and unknown species. We've only just begun to scratch the surface.
So where do we go from here? What are the next steps in this cosmic detective story?
Well, the obvious next step is to find more of these dormant black holes. This discovery has given us a roadmap, a way to identify them. And with the power of the James Webb Space Telescope, astronomers are eager to start the search.
So it's like a cosmic treasure hunt with the JWST as our trusty metal detector.
That's a great analogy. By finding more dormant black holes, we can start to compare them, see how they differ from their active counterparts, and get a better understanding of their overall population.
And that will help us refine our models of black hole formation and evolution.
Exactly. We can start to ask more specific questions. How do black holes switch between being active and dormant? What triggers these transitions? And perhaps most importantly, how do these silent giants influence the galaxies they inhabit?
It seems like there are endless questions to explore. I'm already hooked on this story.
Mm.
But before we get too carried away, I want to circle back to something we touched on earlier, this idea of direct collapse. Such a radical concept, a black hole forming without a star. Can you walk us through that process again?
Of course.
Yeah.
So imagine the early universe, a time when everything was much denser and hotter than it is today. There were these vast clouds of gas, mainly hydrogen and helium. the basic ingredients for stars. But sometimes these clouds were so massive and so dense that they reached a tipping point.
A tipping point? What do you mean?
It's like inflating a balloon until it bursts. The pressure inside gets too high and boom. In the case of these gas clouds, the tipping point is when gravity becomes so strong that it overwhelms everything else.
So instead of slowly forming a star, the whole cloud just implodes on itself.
Exactly. And because there's so much mass concentrated in one spot, it collapses directly into a black hole. No star required.
That's wild. So
Yeah.
direct collapse is like a shortcut, a fast track to forming a black hole. And it might explain why we see these supermassive black holes so early in the universe.
Precisely. It's a more efficient way to form a black hole, especially in the extreme conditions of the early universe. It's like building a house in a day instead of month.
Okay, that analogy works. So direct collapse is a key part of the story, potentially explaining how these supermassive black holes got so big so fast.
Exactly. It's like finding a missing piece of a giant jigsaw puzzle.
This whole thing is just blowing my mind.
Yeah.
It makes you realize how much we still don't know about the universe.
That's the beauty of science, isn't it? There's always something new to discover, always a mystery waiting to be solved.
And it's not just about black holes, right? This discovery has implications for our understanding of the entire early universe.
Absolutely. It challenges our assumptions about how structures formed in those early days. We used to think it was all about things gradually merging, like building a Lego castle brick by brick. But this massive black hole, sitting pretty in a relatively small galaxy, suggests there might be other ways to build those cosmic castles.
So maybe some of those early black holes skipped the whole merge smaller galaxies step and just went straight for the supermassive size.
That's what this research is hinting at, and it's pretty revolutionary. It's like finding out some skyscrapers were built in a single day instead of over years of construction.
Okay, I'm starting to see why this is such a big deal. It's not just about one black hole taking a nap. It's about potentially rewriting the entire history of the early universe.
You got it. And this is where things get even more exciting. If this one dormant black hole is challenging our assumptions, imagine what other surprises might be lurking out there.
It's like we've only just opened the first page of a cosmic mystery novel, and we're already hooked. So what happens next? What are the burning questions that astronomers are going to tackle now?
Well, for starters, they're going to be on the hunt for more of these dormant black holes. Now that we have a better idea of what to look for thanks to the James Webb Space Telescope, it's like having a new set of lenses to view the universe.
It's like we've just upgraded our cosmic detective kit.
Exactly. And with every new dormant black hole we find, we get more clues to help solve the puzzle of how they form, how they evolve, and how they influence their galactic neighborhoods.
I can't wait to see what they uncover. It seems like every new discovery just leads to more questions, which I guess is what makes science so captivating.
It certainly keeps things interesting. And it reminds us that even with all our technological advancements, we've only just scratched the surface of understanding the vastness and complexity of the universe.
It's humbling, isn't it, to think that we're just a tiny speck in this grand cosmic tapestry, and yet we have the ability to explore and understand these mind-blowing phenomena.
It truly is. And it underscores the importance of continued scientific exploration, of pushing the boundaries of knowledge, and of never losing our sense of wonder and curiosity.
Well said. And speaking of curiosity, I know our listeners are probably eager to learn more about this groundbreaking discovery. Where can they go to delve deeper into the research?
Excellent question. The original research paper is titled A Dormant Overmassive Black Hole in the Early Universe, and it was published in the December 18th, 2024 issue of the prestigious journal Nature. The lead author is Ignas Judzbalis from the University of Cambridge.
So if our listeners are feeling really ambitious, they can check out the full research paper.
They can. But if they want a more accessible overview, I highly recommend the article by Ryan Whalen in The Debrief, published on December 22nd, 2024. It's titled James Webb Space Telescope Spots Monstrous Black Hole Lounging After a Cosmic Feast. It does a great job of breaking down the key findings and implications of the research.
Perfect. We'll make sure to include links to both the research paper and the debrief article in the show notes for easy access.
Excellent. Good.
Well, this has been an absolutely fascinating deep dive into the world of dormant black holes and the mysteries of the early universe. Thank you so much for guiding us through this incredible discovery.
It's been my pleasure. Always happy to talk about the wonders of the cosmos.
And to our listeners, thank you for joining us on this journey of exploration. We hope you've enjoyed this deep dive as much as we have. Remember, the universe is full of wonders waiting to be discovered, so keep looking up, keep asking questions, and never stop exploring.